Good day everyone! In this video, you will be learning the introductory concepts of basic calculus. You will gain an understanding of the concept of the limit of a function. There are different ways to determine the limit of a function, but in this video, we will illustrate the limit of a function using a table of values and a graph of a function. You have learned in your previous mathematics lessons on how to construct a table of values and plot all those points in a Cartesian coordinate plane. But before we proceed to the lesson proper, it is necessary to have an enough understanding and appreciation of the concept of limits. But what is a limit? To appreciate the beauty of mathematics, let us consider some real-life examples. Suppose you have rubber bands and boxes of marbles. The boxes of the marbles have varying weights. You wanted to investigate if how strong is your rubber band and what is its capacity to lift the marbles of increasing weights. After trying all the boxes of marbles, you have observed that the rubber bands will break or tear if it lifts boxes of marbles having a weight of 0.5 kg or more. In this example, you might come to conclude that the rubber band will break if it will reach its capacity to lift the objects. In other words, the rubber band has its own limits in lifting the objects. Another live illustration of the concept of limits is the password in your cell phones. For our security and privacy, we always set a password. For instance, you have a friend who wants to open your phone, but you don't want to give him or her a password. However, he or she can guess what your password is, but he or she only has 5 attempts to guess your password. If it happens, he or she entered the wrong password after 5 attempts, your phone will be locked for a minute. I have here other examples where the concept of limits can be found in real-life contexts. Rate limit of a bridge. Credit limit on a loan. We have also limits in withdrawing our money in ATMs. Our speed limit of a car. When we ride in an elevator, there must be a limit or capacity, and there must be also limit in eating. You might be familiar also with the advertisement for this ice cream. Hanggang saan naabot ang 20 pesos mo? And we must also remind ourselves to limit the use of plastics. Everyone has their own limitation, maybe as humans or even technologies. Knowing your own limits help you understand why some things are favorable to you and some are not. It is customary to have a brief background before we begin the proper discussion on the limits of a function. The concept of a limit is the building blocks on which all the underlying concepts of calculus are based. It helps us to describe in precise way the behavior of f of x when x is close but not equal to a particular value c. Limits are the backbone of calculus, and calculus is called the mathematics of change. We will consider functions as a single variable and study the behavior of the function as its variable approaches a particular value, a constant. The variable can only take values very close to the constant, but it cannot equal the constant itself. However, the limit will be able to describe clearly what is happening to the function near the constant. We have here the definition of the limit of a function. Let f be a function defined at every number in some open interval containing c. except possibly at the number c itself. If the value of f is arbitrarily close to the number L for all the values of x sufficiently close to z, then the limit of f of x as x approaches c is L. And this is how we write the limit of a function. Limit of f of x as x approaches c is equal to L. To further illustrate, let us consider the given function. And we read this as the limit of x plus 2 as x approaches 4 is equal to 6. The symbol lim stands for the limit of. The x plus 2 is the function f. Then we have as x approaches 4 and the value 6 is the value of the limit. We will now determine the limit of a function using the table of values. Let us consider this example number 1. Using the table of values, investigate and determine the limit of the function. Limit of 1 plus 2x as x approaches 3. So we need to set up our table of values. First, we need to assign values of x, but when we assign values of x, the x here must be approaching to 3, as indicated here. So we can assign any values. Suppose we have 2, 2.5, 2.9, 2.99, 2.9999. Notice these values are approaching to 3 from the left. Also, we can assign any values of x, this time from the right. So we have, for example, 4, 3.5, 3.1, 3.01, 3.001, and all of these values are approaching to 3 from the right. Again, we can assign any values. It doesn't necessarily to be like this, as long as they are all approaching to the given number 3 from the right side and from the left. You have learned also on how to determine the value of f of x if we have the values of x. So, for example, you have x is equal to 2. The value of x, or the value of f of x, is by substituting in the given function. That is why we have the value of f of x for x is equal to 2 equals 5. And by doing the same thing and by following the same principle, you will come up with these values of f of x. Now take a look as our x approaching to 3 from both sides. What have you noticed with the values of our f of x approaching from the left and from the right? The value is actually approaching to a number 7. From here, we conclude that the limit of 1 plus 2x as x approaches 3 is equal to 7. Let us now determine the limit of a function using the graph. We will follow or we will use the same given function. But take note that in graphing, we must have also table of values so that we have an ordered pair to be plotted in the Cartesian coordinate plane. So to do this, we have here our Cartesian coordinate plane. Let us plot all those points. We have 2, 5, 2.56, yeah, as what you have noticed, connecting all the lines, we can see that our f of x is approaching to a value 7. Therefore, that the limit of 1 plus 2x as x approaches 3 is equal to 7. Let us now consider the example number 2. Using the table of values, investigate and determine the limit of the function. Limit of x squared plus x minus 6 over x plus 3 as x approaches to negative 3. So we need, however, this function can be simplified into its simplest form. We can factor out the numerator, so we have, then by simplifying this expression, we have x minus 2. This means we will now determine the limit of x minus 2 as x approaches to negative 3. However, notice that this function is similar or equal to this because we just did simplifying this function into this one. At this time, we need to set up our table of values. We can assign any values of x as long as the values of x are all approaching to negative 3. So from the left, we can assign, and from the right, and we have now to look for the value or values of f of x to the specific values of x. By looking into the table of values, the f of x is as x approaches to negative 3, the value of f of x is approaching to the value of negative 5. Therefore, the limit of a function is equal to negative 5. Let us now determine the limit of the function using the graph. So we need also our table of values, and these values will be plotted to our Cartesian coordinate plane. So to do this, we have then we have to connect all these points. Notice that as x approaches to negative 3, the value of f of x is approaching to a specific number, which is negative 5. Therefore, the limit of the given function, as can be seen on the graph, is equal to negative 5. It's now your turn to try some examples. You're going to construct the table of values for the given limit of a function. Limit of x squared minus 2x plus 4 as x approaches to 1. Then, using the table of values, construct the graph of the given function. Then answer the letter C question. Does the limit of the function exist? Explain why. At this point, you may now pause this video for you to have an ample time to answer the questions. This time, you have to check your answers. These are some possible answers that you can have. For letter A, for letter B, and for letter C. And that ends this video presentation. As a sort of a reflection, solving a limit is like watching a basketball game. When you choose seats, you would want to be as close to the action as possible. You would want to be as close to the players as possible and have the best view of the game as if you were in the basketball court yourself. Take note that you cannot actually be in the court and join the players, but you will be close enough to describe clearly what is happening in the game. And that's the concept of a limit.